Alright class, in this lesson we're going to take a look at solving equations. And in order to solve equations we have to use what's called the zero product property. And the zero product property is this right here, where you've got A times B equals 0. What that means is anything times anything else, if you have it equal to 0, what that must mean is that either A is equal to 0 or B is equal to 0, or they're both equal to 0. And so why that's helpful is because if I have like 3 times x and the answer is 0, that must mean the only thing that I could put in here that works would be 0. So x would have to equal 0. And likewise, if I had something like 10 over for b and times z, and the answer was 0, the only way for that to work would be for z to be 0. So if I put 0 in there, 0 times 10 would be 0. So it's a very useful property when we come to equations like this particular problem, where I've got two parentheses set equal to 0. Well, what's happening here is either this parentheses has to equal 0, or this parentheses has to equal 0, or they both are, in order for this to become a true statement. Because we're saying that it is a true statement, it is in fact equal to 0, so one or the other, or both, has to be 0. So we assume that's true, and set x plus 6 equals 0, and set 2x minus 3 equal to 0. You make the break at the multiplication between the two parentheses, okay, to become the two equations. Once you have your two equations, you solve each one individually as if they are their own separate problem. So I solve for x in the first equation by subtracting 6 from both sides, and that gives me x equals negative 6. And that is one answer for x. That makes this equation true. Now I go to the second equation and do the same thing, solve for x. I add 3 to the other side, and then I get 2x equals 3, and then I divide by 2. And the answer for x in the second equation is x equals 3/2. So there are actually two answers for x equals negative 6 and x equals 3/2. Either of those numbers, if I plug it into the original equation, will make the equation equal to 0, which is why that is a solution. So x equals 6, negative 6, and x equals 3/2 are your answers, which means that if I plugged in 6 right here, this would become 0. If this is 0, 0 times anything is 0, so this is a true statement. So now, if I was to take 3/2 and plug it in for x here, what that would cause would be, this would turn into 3 minus 3, which is 0. So if this is 0 times whatever the first parentheses is, doesn't matter, the answer will be in fact 0. So again, I'm just showing you that the answers, whatever you get, if you plug them back in, it should make the equation equal to 0 and make the true statement. So now, sometimes we don't have it set up right away so that I can use the zero product property. First I have to factor, which is why I went through the whole lesson and why you learned factoring completely. Now that we know how to factor completely, we're going to use that in solving. The only difference is between what we had before was we didn't have this equal 0 part. I would have had to just factor that. Well, that's kind of the way you approach the problem. But in the end, we do have to deal with the equal 0. But for now, ignore the equal 0 and check for how to factor that completely. You'll see that they both have a 4 in common and an x. And if I pull out a 4x and divide each one by 4x, this will turn out, the result will be x. And if I divide this by 4x, this will give me negative 5, and the x is canceled. Okay? So this would have been the result if I was just factoring completely. Well, now I've got one more step. It's supposed to be equal to 0. So the equal 0 part comes back into play. And what I'm seeing is that this is the zero product property. I'm supposed to separate it at the multiplication between parentheses, and that would be right here. Okay? Really look for parentheses, and then this is one group. So you set this first group equal to 0, the 4x equals 0, and the second one, the x minus 5, equals 0. Okay? Now that you've separated them, you solve for each x. So the first one, the left side, I divide by 4 on both sides, and 0 divided by 4 is 0, so x equals 0 is one solution. That will make that first equation true. In the second equation, I just have to add 5, and that gives me x equals 5 as a second solution. So what that means, in the original equation, if I plugged in 0 or 5, the answer would be 0, and it would make that equation true. So let's check that. So x was supposed to equal 0, so if I plugged in a 0 here, I see that I multiplied both of these times 0, and the answer is, in fact, 0. And the other solution that I had was 5, so I put 4 times 5 squared minus 20 times 5 equals 0. Now, this would give me 4 times 25, which is 100, minus 20 times 5, which is also 100, and 100 minus 100 is, in fact, 0. So all I'm doing here is just saying that these check off as correct solutions. You don't actually have to do this in your homework. As far as your homework is concerned, your assignments are concerned, you just have to say x equals 0 and 5 is your solution set. It might ask you to put it in brackets as a solution set. That's just saying your two solutions are 0 and 5. Okay. And then finally, here's one more solving by factoring problem. There's actually two ways you could do this problem. You don't have to solve by factoring or the zero product property. One old method of doing this would be solving by the square root method. So in other words, if I was to just work on getting z squared by itself, I could divide by 9 and get z squared equals 9. And then you could solve by square rooting both sides, because to get rid of a square you could square root, and that would give you z equals, the square root of 9 is plus or minus 3. So you actually have two solutions, plus or minus 3. Now that's the same solution I'm going to get doing the zero product property way. To do the zero product property way, this equation needs to be equal to 0. So to do that, I need to take my 81 and move it to the other side by subtracting it. Okay, and we get 9z squared minus 81 equals 0. So now this looks like the last problem where I have to factor. Well, this is actually, there's two ways to factor. It is difference of squares now, but I should also work on pulling out a GCF. So the GCF is 9, and then I'm left with z squared minus 9 equals 0. And then to continue to solve, you need to have two parentheses where there's, or two variables. So I don't want to set 9 equals 0 and z squared minus 9 equals 0. I know there's multiplication there, and some of us might think to do that. But I actually want to get rid of this 9 by dividing it from both sides. And what happens there is 0 divided by 9 is still 0, so you just got rid of that. So now you're left with z squared minus 9 equals 0. And then hopefully we notice that this is difference of squares. I should rewrite this to be z plus 3 and z minus 3 equals 0. And now that I've got my two parentheses separated by multiplication, now I would set the first one equal to 0, and then z minus 3 equals 0, and then solve each equation. And so this first one, you're going to subtract 3 from both sides, and you're going to get z equals negative 3. And then you're going to add 3 to both sides on the second equation and get z equals positive 3. Now again, these are the same solutions I had earlier, a little bit quicker actually doing the square root method, but it just suffices to show that there are examples in problems where you can't do the square root method, but you need to, or you can do the square root method, but you might need to solve by setting it equal to 0 first. So if there's ever anything with a number on the right hand side, we need to first make it equal to 0 in order to factor and solve by the square root method. So if you were to want some steps, first thing would be to set it equal to 0, and then step 2 would be factor, and then step 3 now would be solve using the zero product property, ZPP. Okay? So I'm going to have some more examples using trinomials in the next lesson, but these ones are the ones that I've got for binomials.